Hello students, today I am going to discuss 3D transformation in computer graphics. 3D transformation in computer graphics, and after that I will show you the implementation of the 3D transformation in TurboShell. So today I am going to discuss 3D. First of all, to understand what is the 3D transformation, why we are using the 3D transformation in computer graphics. So here the 3D transformation takes place in a three-dimensional space. So 3D transformation is important because it is more difficult than 2D transformation. It is more complex. So it is useful in changing the position, modifying the size, orientation, shape, etc. of the objects. So it is useful to modify the objects. Okay. So there are following techniques uh, for 3D transformation, that is translation, rotation, scaling, reflection, and shape. But in this video, I am going to discuss only three techniques, that is translation, rotation, and scaling. So in this video, I will show you about the translation technique. Again, in next video, I will show you the rotation technique. Again, and on third video, I will show you the scaling technique. Okay, I will I will show you the implementation also. So first of all, I'm talking about the translation. When I'm talking about the translation, the question is that what is translation? Why we are using the translation in the computer graphics? So translation transform uh, the object by simply moving the object at each point by a certain amount horizontally and a certain amount vertically also. So here we move the object at each point uh, by certain amount of horizontally and certain amount vertically. Okay. So if we have the original point or initial point of the object is x1. Okay. And after the transformation, the new point of the object will be the x1 and y1. See, there is a formula for a translation. Okay. So here the x1 y1 is the value of the x the point of x y after the translation. So how we'll calculate that? The new value of the x point will be the x1 with the addition of the original point plus e. Where e is the translation factor. At what distance you want to move the object along x-axis or y-axis or z-axis. Okay. So here it is the addition and the original value of the coordinates will be the addition of the previous original value plus translation factor. So in 3D coordinate system, so we have the three vertex, that is three axis x, y, and z. So for this we have a three translation factor. Okay. They have a three translation factors. So we use this process when we need to translate all the coordinate of the object. So for drawing the 3D object, this on this stage. Here we will use the 3D function, bar 3D function to draw a 3D object. So bar 3D function we are using because it is already defined in the graphics.excel file, which is used for the computer graphics program, the interface. So this is the syntax of the bar 3D function. Okay. So by this function only we can draw the 3D object. So, and bar 3D is used to draw three-dimensional rectangular shape. So for this we have how many parameters? Left, top, right, bottom, depth, and top length. These are the parameters of the 3D functions. So for this, we are by using 3D function. First of all, that before translation, we use this bar 3D functions to draw a rectangular shape, and after that, we will take the translation factor as an input. And after giving the input as a translation factor, again we will use the bar 3D functions with a new value of the all the parameters. Okay, all the parameters that after the translation where the point object would be it will show like this. So consider, let us initialize, let us take some point object which have to move from one position to another position in a 3D plane. So for this we will initially take the coordinates of the object as a x old, y old and z old. Okay. And after translation we will have the new coordinates, that is x new, y new and z old. So for because here the three coordinates we have, so for this we will take the three translation vectors along each axis. So along x-axis we have the translation vector will be dx, for y-axis dy, and for z-axis it is dz. Okay. So here the translation vector will define the distance along any coordinate which the points have to the object has to move. So here the translation factor define the distance at the point coordinate at the point object along any x, y, z coordinates which the distance the point object have to move. So here you can see in this diagram here the point object originally it will be here, and for the point object the value of x coordinate and y coordinate z coordinate will be here. Okay. So after translation the point object lies here, and for this it will have a new value of x coordinate, y coordinate and z coordinate. So there is a calculation to get the new value of the x coordinate, y coordinate and new value. How will calculate? The value of the new x coordinate will be the sum of the value of old x coordinate plus translation factor. So like this we can calculate all the new value of the all coordinates by adding the value of the original point plus translation vectors. Okay, in matrix forms, if we want to calculate, so in matrix in 3D translation, in matrix form, it will be like this. Okay, so now I am going to show you the implementation of this. Okay, so this is the implementation of the 3D scaling. Okay, see, see here. So here I have starting. See, so here, see here we have used the 3D functions before translation to draw the rectangular box. After that, we have to enter the translation vector at what distance our point object have to move along all the coordinates. Okay. And then after translation, again we have used the 3D functions. Okay. To get the new value of the all the coordinates. So now I'm going to run it. Here I'm giving translation vector as a and after translation object will be like this. Thank you. I hope you understand. Thank you so much.